This is an example of a dependent or independent samples t-test. So here we're going to look at and compare two independent groups, two completely different groups. So as you can see, the formulas here, this was the type of test with the longest type of formula. So we're just going to take the difference between two means. And the actual technical formula would have had another component here, which is a mu1 minus a mu2. But since those are considered to be zero, I didn't actually put it into the formula because we really only need this. So because that component is based off of the null hypothesis, which is that there's no difference. So we do have the standard error, the difference between means. And for the statistic, our degrees of freedom is the degrees of freedom of one group plus the degrees of freedom of the other. You can see here that our standard error for the difference of means is this pooled variance over the sample size of one group plus the pooled variance over the sample size of the other group, and we take the square root of that. And the formula for pooled variance is simple. It's just adding the sum of squares of both groups and putting that in the numerator, and adding the degrees of freedom of each particular group and setting that as a denominator. So let's go ahead and start with the question. Do you view chocolate as delicious or fattening? Your attitude may depend on your gender. Researchers examined this question in a group of n equals 9 males and n equals 15 females. Specifically, the scores obtained measure the level of concern about negative aspects of eating between the two groups. The males had an average m equals 33 with sum of squares equals 740, while females had an average m equals 42 and sum of squares equals 1240. Use a two-tailed test with alpha level equals 0.05 to see if there is a significant difference between males and females. So let's go ahead and start. We're always going to start with stating the null and the alternative hypothesis, but right now let's just underline the information that we know we're going to need. So we're going to need the sample sizes. We're going to need the means, and the sum of squares for each group. And we're going to need the female mean and sum of square. And we're going to need to know the alpha level as well as the type of tail. So let's start with our null hypothesis. The null hypothesis is that the difference between the two population means is equal to 0. And the alternative hypothesis is that the difference between the two population means is not equal to 0. Now at this point, we can actually start setting up to draw the sketch. So for this, what we need is we're going to need the alpha level, which is given to us. That's 0.05. We know that it's going to be a two-tail. We also need the degrees of freedom. So the degrees of freedom for this would be the degrees of freedom for the statistic, which includes the degrees of freedom for each group. So that's degrees of freedom 1 plus degrees of freedom 2. So the degrees of freedom for the male group, there's 9. So 9 minus 1 is 8. So we have 8. And for the females, their sample size is 15. So the degrees of freedom is 15 minus 1, which is 14. So our degrees of freedom is 22. Now we can actually figure out what the t critical values are. So these are going to be the cutoff values when we draw our sketch and where we begin shading the tail. So we know that we're going to look at the two-tail 0.05 and we have 22 degrees of freedom. So we're going to pull out our table, and again we're going to look at the first two rows and identify that we're going to be working with the two-tail, and we're going to scan row-wise until we get to 0.05, which is the level that we want to set. Now we can scan downward until we find the degrees of freedom, and again the degrees of freedom is specified in the leftmost column here. So we're just going to go down, scroll down this third column until we get to 22. So we start scrolling, we're scroll, and then we get here to 22, and we see that the cutoff is 2.07. So we're going to have plus or minus 2.07 for our cutoff. And then we can actually draw our sketch. And we're going to do a two-tail. And this one is centered at 0 because we want to see whether there's any difference from 0. Our cutoff values are 2.07 and negative 2.07. Okay, so now that we did our sketch, we can actually start working out, calculating the statistics. The first thing we're going to want to do is calculate the pooled variance. So we're going to have to get to this equation. For that, we need the standard error. But in order to get the standard error, we need to find the pooled difference. So let's find the pooled difference by simply adding the sum of squares of each group and setting that over the degrees of freedom of each group. Okay, so let's make a little room here. I'll do the formula here on the side. Pooled variance equals sum of squares 1 plus sum of squares 2 over degrees of freedom of the first group, degrees of freedom of the second group. So the sum of squares, we have 740 plus 1240, and we're going to set that over, we already found the sum of squares of the two groups, so that was that was 22. Okay, so let's start punching that into our calculator. I actually got to pull up my calculator here. I forgot to do that. So we're looking at 740 plus 1240. 740 plus 1240, which is 1980 over 22. So that gives us 90. So our pooled variance is 90. So now we can find the standard error of the difference of means. So the standard error, that was a different formula as well. So if you guys look down here, the standard error is, oops. Sorry about that. I'll just fold the paper. All right, so the standard error is the pooled difference, or the pooled variance over the sample size of the first group plus the pooled variance over the sample size of the second group, and take the square root of that. So you're not going to see the formula. I'm just going to copy it on the paper and then we'll work through it. So let's find a little space down here, and we're going to do the standard error of the difference of means. And that is the square root of 90 over the first sample size, which is 9, plus 90 over the second sample size, which is 15. So that gives us, let me do it on the side here. That gives us 90 by 9, that's 10. And 90 divided by 15, that's 1, 2, 3, 4, 5, 6. So we actually have the square root of 16, which is 4. So our standard error is 4. Now our final formula is simply to take the difference of means, so that's M1 minus M2. And then this was the other component of the formula that I didn't bother putting in, mu1 minus mu2, but that's just equal to 0. And this is over the standard error of the difference of means, which we just found. So notice that this component is 0, so we're not even going to bother with it. We're just going to take the means and find their difference. So we're going to do 33 minus 42, and then set that over 4. So that gives us 9/4, which is 9 divided by 4, which is 2.25. So our t-value is 2.25. Well, negative 2.25, I'm sorry. But really, we're just looking at the absolute values and comparing the absolute values of our t obtained with our absolute values of the t critical cutoff. So if we got negative 2.25, so we're like over here in this rejection region somewhere, right? So t equals negative 2.25. If I would have done this the other way around, it just would have come out positive, and I would have gotten 2.25, and I would have been in the rejection region anyway. So you could see here that our t obtained is in the rejection region. Therefore, our very last decision is to reject the null hypothesis. So that's to say that the groups, the two different groups of males and females, do actually show a significant difference in their attitudes towards unhealthy eating. Okay, so I'll leave some of the work there for you guys to look at. But that's pretty much it. Okay, I'll see you in class.